this video, I'm going to show you how to analyze the data that we obtained from our subject in class using the BioPack Analysis Reader program. As soon as you open the program, you'll be prompted to open a data file, and we performed lessons 12 and 13 on our subject in class. All right, you're going to select lesson 12. So Jared L12, and that was the first test that we did on our subject. And this is the spirogram, and we're going to take a look here and see that we had the subject breathe normally for, well, Jared in this case took 5 normal breaths. Our subject will have taken 3. And then a deep breath in, a deep breath out, and then returning back to normal breaths. The scale, the vertical scale here is in liters. This is the volume in liters. And the horizontal scale is in seconds, so that's time. We can show the grid, which will help us to navigate the volumes and the seconds a little bit easier. Okay, so what we want to do is we want to take some measurements. So it's the eye tool that we use to take these measurements, very similar to what we did with the ECG. So let's go ahead and select the eye tool. And let's measure for tidal volume first. And so we want to use the third breath. So let's see right here. So we're going to place the eye tool between the low peak and the high peak because we want to see the difference. We want to measure the difference between those two. So we actually are going to look at delta here. So delta tells us we're at 0.71 liters. Okay, so that's our measurement for inspiratory tidal volume. And then the next thing we want to do is we want to do the same thing for expiration. So we look at delta and we see it's at a 0.87. Okay, so we want to take the average of those two, and that will give us the tidal volume. And the next thing that we're going to measure is vital capacity. So where do we measure that? Well, we want to go to our maximal inspiration and maximal expiration to be able to measure that. So we want both peaks to be in our selection because we're going to use the P to P now, the high and the lows. So we just want to make sure that we get a bit of the peak here. And, you know, it's a little bit of trouble to find the center of the peak. So I think what I'm going to do is I'm going to change the time scale. So I just click on the time scale. If I can get my act together here. There we go. And I'd like it to see maybe between 20 and 50 seconds of the scale. And that opens things up for me. It's going to make it a little bit easier to select now without straining my eyes. So we want to go, we want to have both peaks within our selection. So I'll go a little bit before the inspiratory peak and go a little bit beyond the expiratory peak. And we're going to look at the P to P value now. And the P to P value is 4.28 liters. So that's our vital capacity. Now we can also measure inspiratory reserve volume and expiratory reserve volume. And the way that we want to do that is we want to actually use the delta measurement again. So what we want to measure here with inspiratory reserve is from the peak of normal inspiration to the peak of maximal inspiration. We want to get the difference of those two. So we don't want to use the P to P value, but we want to use the delta value. So 2.13 liters for inspiratory reserve. And then we can do the same kind of measurement for expiratory reserve. So what I want to do here is find the low point of expiration, of normal expiration, and the low point of maximal expiration. And we want to see the difference between those two, which is about 1.4 liters, give or take. One thing I want to mention before we go on to the second experiment is that if you notice the valleys here of expiration don't go below 1 liter. And the reason for that is that the computer has put in a default value of 1 liter for residual volume. Now the normal values for residual volume are for males around 1200 milliliters or 1.2 liters, and for females it's at 1100 milliliters. Okay, so if you are not sure what residual volume represents, make sure you bring it up in class and we'll talk about it. So let's switch over now to lesson 13, which is the second experiment that we did with our subject. And you're going to notice something that looks a little bit different than what we did in class. And so the reason it looks different is it doesn't look like a regular spirogram is because we had our subject take a deep breath in, a maximal deep breath, and then we had them force it out as quickly as they could, as maximally as they could. And then we selected this forced expiration and asked the computer to calculate forced expiratory volume. And what the computer did was it took that section of the graph and inverted it, and then it turned it into this graph. And so what you'll see here is that we have 3 seconds worth of the expiratory volume. And actually I like to grab a little bit more than 3 seconds. And so the first measurement that we're going to take is forced vital capacity. And you can kind of estimate that here at about 4.5, but if we use the I-beam tool, we can bring it out to the top part of the peak here, and we see that it's at 4.47, close enough, close to 4.5, and that's our forced vital capacity. The second measurement you're going to take is that you're going to take the forced expiratory volume within 1 second. And if we look at the P to P, we've got 3.8 liters. And the second measurement you're going to take is forced expiratory volume in 2 seconds, which is at 4.45 liters, about 4.5 liters. And then you're going to figure out forced expiratory volume in 3 seconds. Now again, they didn't go beyond 3 seconds here. I like to go a little bit beyond because I like to see if the person is still expiring beyond 3 seconds. If so, it may not have been quick enough. You may want to redo it. Or maybe the person has an issue and they can't get all their air out within 3 seconds. So that's the measurements that you take on your data. And you're going to do some calculations with that. And that'll do it. All right, see you in class.